Okay, so any question, any query before starting, like we discuss from last discussion.
No, sir. No, sir. We're good.
Now sharing a screen.
Sure, sir.
So it's visible.
Yes, sir. It's visible.
So we already discussed this architecture in the last discussion.
Mm-hmm.
Moving forward. So next slide.
Mm-hmm.
Basically, we say NMS planning flow. But for us, I will say, let us understand the
Mm-hmm.
process of signal flow, like we discussed in previous slide, physical
Mm-hmm.
physical connectivity of the infrastructure and grouping of infrastructure, starting from infrastructure like equipment, network elements, to the order booking, conversion, and billing. So that portion we have discussed in previous slide, but that is in a infrastructure way. Same infrastructure in terms of functionalities. What layer performs what function, and how they are associated with each other, and that
This is the physical connectivity of infrastructure, right?
in a previous slide, but not now. It's a logical interpretation of this physical infrastructure. Logic.
Could you please repeat? Could you please
Yeah.
repeat that?
This interconnected physical infrastructure, how the logical signal flow from this network element layer to the BMS layer, that we will discuss.
Okay.
Because you once deployed the physical infrastructure, then on top of this, protocols, applications, all we need to do the integration. So we can say logical integration. So logical resources, basically resources can be categorized into two ways. First way is physical resource. Second one is logical resource.
Okay.
So there are physical resource and logical resource.
Okay. Yeah.
Now we will understand what is this logical resource and how this is very important point for any network or any 2G, 3G, 4G or any data network infrastructure. So ultimately already we discussed everything. Ultimate is the physical infra. So what physical infra as a platform is there. On top of this, logical infra you need to plan as a subject matter expert. So once sitting into network operation center, just like Splunk you discussed last time, or SOC, security operations center, you only control remote via remote. That is logical resource, not the physical resource. For the physical resource, field team is required, because this is physical inventory. So physical custody by the physical team, physical field team. But sitting into NOC, logical resource you need to control via application. And what is this application? NMS or EMS or any other customized software, OSS, BSS. So that portion we will discuss. The previous slide, very bottom first slide was network element layer. It was physical layer, correct?
Yeah.
Coming to this, categorization is there. Access, trans, IP. Trans is basically a transmission. Trans is transmission. Here in this case, network scale planning. Network scale planning. So basically, this 5 layer you can check it out. 1, 2, 3, 4, and 5 layers been categorized into 3. Any layer, any management layer, and service management layer. Service management is OSS. Any management NMS layer, this is NMS, and third one is the any layer. Correct?
Okay.
Out of five, this 1, 2, top is very in the last and top. This is separately 1 to 1, but this portion you can check it out. First is network element layer is this one number. One number, and second and third from bottom. Second and third is your NMS.
Yes.
Fourth and fifth is OSS.
Understood. Okay. So you actually showed me from the old to the from tradition to modern. Like first you gave me the 3-layer framework, then you told me how it breaks into 5-layer framework. Now you're giving me a detailed flow of 8-layer, right?
Correct.
Understood.
So processes, this 5-layer logical processes of signal flow, total 8 layers. 8 layers.
8 layers. Okay.
Yes. So if you see this picture, if you remove this right hand side definition, then you can check logically only 3 layers.
Yes, yes, that's right. Understood, understood.
So once we handle the architecture or any infrastructure or process or operation we need to handle, in that case, we need to go inside of this 3 logical layers. So first is network scale planning. Scale means, have you heard the word capacity planning?
Yes.
What does it mean, capacity planning?
Capacity planning would be based on your what do you say, particular device or any kind of application, saying that okay, my Splunk has got a capacity of 95% to sustain. If it actually goes beyond, it can breach, and due to which there could be a lot of downtime or other issues can happen, or other application may go down or fail.
Correct.
So you need to have a capacity plan for everything, like your load balancer.
Correct. So here is the point. Just now we already discussed physical infrastructure and logical infrastructure. Correct?
Yeah.
So logical will run on top of physical infrastructure. Discuss. So these are the inventory resources, and resources can't be like a infinite. So that means some quantitative definition for the resources.
Yes.
Limitations means you can just quantify. So wherever you can quantify, that means at some point you will reach at the limitation. You will exhaust all your quantity.
Yes.
But it doesn't mean that 20 years capacity I can plan today. It doesn't mean that. At least, yes, I can plan for 5 years or 10 years.
Yeah.
Invest the money
For a long term.
Techno management for 20 years into the network or any technology. But yes, I plan my business, IT business or telecom business, at least 5 years without any upgradation, at least, and 5 to 10 years with upgradation little bit. I should run for 10 years without investing too much money on again the revision of the network. So that means network scale planning is suggesting what capacity, what technology, what capacity means physical and logical both. Physical and logical both we need to plan. We are doing in network scale planning. Now, physical inventory and logical inventory. What does it mean by this logical inventory? That I am explaining it to you. For example, let us assume we are connecting our laptop with switches or in the office with router kind of thing, correct? On a Ethernet port.
That's right.
Have you heard Ethernet port?
Yes.
So capacity or interface types of Ethernet port is 100 Mbps, that is fast Ethernet.
Yes.
1000 Mbps, that is gigabit interface.
Gigabit interface, correct.
And 10G interface. So 3 flavors are coming, either in laptop or on the switch or any other device, even your broadband router nowadays, correct?
That's right.
3 flavors in interfaces for Ethernet is coming. So how many interface I should plan? This is a physical quantity.
Yeah.
Now let us assume somebody wants 500 Mbps bandwidth. 500
Mbps bandwidth.
Mbps bandwidth, and you have only fast Ethernet on your router or switch.
Yeah.
Be able to connect it. You got my question?
So somebody is requesting for 500 Mbps, and I have only fast Ethernet. You're saying, will I be able to connect it? That depends on what is the speed I have, right?
What does it mean by speed?
I mean, what is the capacity I have? Fast in the sense like what is the no as a backend, what is the capacity I have in that case? Now, for example, 500 Mbps is what you're requesting. If I have 100 Mbps, then it is difficult.
For example, see, this is your switch. You connect your laptop.
Yeah.
End user. This is my switch. This is my internet cloud. Internet. Here I have 1000 MB speed, 10 gigabit, 10G port.
Okay.
This is 10G port. This is my fast Ethernet, 1FE.
Okay.
And all my ports are 1FE. I have a ports. I want to connect 500. How to connect my 500 bandwidth over here? Another laptop. Because this port is giving you only 100 MB, not the 500 MB. So in this connectivity, I have the planning point 1. I have point 2. Then only I will able to connect end to end.
Yes.
So that means I should plan physical infra this point.
Correct.
First physical infra. Then you say, okay, I have 1 G available. 1 gig available. Port, physical port. Then you will say, connect your laptop. No issue. I will able to connect it. But let us assume you give 100 MB over here. You give this 100 over here because you have FE port only.
Yeah.
And this is 1 gig. So I will be able to pass all the traffic from here.
Yes, I can. Yes, we can do that.
It will be passed on. It will be passed on. It will be passed on. Now I'm saying I got another customer as a broadband, 1 laptop connectivity. He wants 10 gig port.
Okay.
So that means you need to plan 10 gig also on the same switch.
Yeah.
This is physical scale planning.
Physical scale planning. Yeah.
Physical infra.
Yeah.
Now question is, you have physical infra. Now question is, do you have logical infra? Do you have this traffic to pass on 10G?
Yes.
How?
Depends. See, now when you told me here for 500 MB, I mean on your left hand, okay, where you actually told that you want to give it via 500. Okay, we can actually with the planning 1 or planning 2, we can try to give the traffic here. Is it possible?
No. Look, laptop 1 FE, correct? So 100 we allocated. Another port is FE. Again 100 we allocated. So 200 we allocated. 200.
Okay.
Here, here 1 gig. So how much MB we already allocated?
300 MB.
No, 1 gig means
1,000.
So total we allocated 1200 till now.
Okay, this is 1 gig. Okay.
Now I'm saying allocate 10 gig. I have the port, a spare port on my switch because I planned during a scale planning for physical infra. So I have physical port available. But do we have 10 gig bandwidth available to pass on?
Yes, we have.
Oh, we already consumed 1200 MB. 10 gig means 10 into 1000 MB.
Correct. In that only 1200 we have used, right?
So do you have 8800 only?
Yeah.
That means question was, I can be able to allocate 10 gig.
Yes, you can.
No, I have only 8800 left. Not
more 10 gig you're saying. Okay.
Yes, I'm adding customer.
sorry. Okay. More, okay, more 10 gig. Okay, understood. No, you cannot.
That means you didn't stuck with physical infra, but you were stuck with logical infra. So I was trying to interpret this line.
Okay.
So physical infra first, and equally important logical infra as well. So sitting into NOC or as a scale planning, you need to plan both equipment. Yes, the equipment supporting the capacity, process, inside handling capacity, all you need to plan. This comes under logical infra. You got this line?
Yeah. Equipment supporting the.
Yeah, same like servers.
Yeah.
Server has some processing power. And yet, last time we discussed, did you remember this was why OSS has been separated from network management layer? Already we discussed this question. Did you remember?
Because that is into different area, right? Like your finance, billing, your automation, and all. And that is a different. What do you say? You said like till NMS is very important because it is into the network management layer. OSS is all you're into the business, and that is a different stream.
Means we don't need to involve NMS in too much analytics.
Analytics, yes.
Every server has some limitation, some capacity. Capacity. So I was talking about same logical. Although you have physical servers, but every server has its own limitation, quantify scale. So install another server, make it as a OSS server, and let that server involve in processing.
Understood.
So same way here to this network scale planning means physical plus logical both. Now you got it.
Yes, sir. Network scale.
Now coming to the next NMS point, reliability planning. What does it mean, reliability? Once we say reliability, that means we are talking about quality plus uptime. That means we are talking about SLA. Let it be any service, 2G, 3G, 4G, or data or internet or cloud service or AWS. Reliability means quality plus uptime. Any network you will plan, let it be hardware or software or any logical resource, at some point of time it will go down due to any XYZ reason, due to fiber cut, due to any misconfiguration, due to power issues, due to some bug.
Unexpected interruptions.
Yes, interruption kind of could be due to any reason. Hence, you need to plan your physical hardware and logical resource both in such a way so that it should be maximum availability to the customer. That is reliability planning. So how we are doing this? How we are doing this? Let me share with you one example. This is one ring. This is one ring. We deployed one switch over here, one switch over here. They are connected in a ring. Do you know ring connectivity? Have you heard?
I guess, but I don't remember, sir.
Okay. Now this is your 2G BTS. 2G BTS. BTS is tower.
Tower.
Yes. 2G BTS. Here is your cell phone. Connected via wireless to the BTS. And this BTS connected via wireline to the switch. And finally, it is connected to your exchange, MSC or BSC. MSC or BSC is basically exchange.
Okay.
Now let us assume there is any fiber cut over here because it's a fiber. Maybe due to some there is a fiber cut. What will happen?
Downtime.
This ring is connected. Yeah, this ring is connected at one point.
Yeah. On one area, where it has got disconnected, there is an unexpected interruption. So due to which it's a downtime. Some of the applications may go down. It could be anything, XYZ.
No, this is not like that. Listen, what is the ring? Why we ring? How we plan reliability for any network? Even
that is for failover, something
yes,
like failover,
yes,
failover kind of thing.
Yes, so here it was running like that. It was running like that. This was the path.
Correct.
There was fiber cut. So this path is automatically switched over via this path.
Correct.
Now, so now my path is via this way.
Yeah.
So there is no interruption downtime, only shifting of traffic via another geographical path.
Yeah. Yeah.
You remember in cities, if there is a traffic jam on any road, we are trying to find out another diversion.
Another traffic. Yeah. Yeah. We do a failover. Yes.
So this is called reliability. Failover.
Reliability.
Yes.
failover.
Now, only switching is not the important. Switching time is also important.
Yes.
So switching from here to here, industry standard is less than 50 millisecond. You know this one? This is standard.
Yes, that I, yeah, that I know, sir.
So this is acceptable by industry. Switchover, this switchover 50 millisecond is happening on physical layer. So it is recommended any traffic should be in a ring protection. Ring protection, not a linear. Linear means there is one tower. Cell phone is connected on tower. Then I connect one tower to the exchange via single fiber, direct fiber. Only one path. So any fiber cut will be there. This is downtime. And in this case, I will not able to manage my uptime. This is case 1. Now case 2. I have ring architecture. There is no any fiber cut, but there is degradation in quality. In that case also I should switch on. This comes under reliability planning. Means you have the logical resources. That logical resources quality should not be degraded. Even switchover, failover plus quality as well at the same time, it should not be degraded. So this is your physical and logical connectivity plan. So now coming to the connectivity portion. So any connectivity if we plan, so in general term, we can say there are two objects that can be connected via any two cable.
Yeah.
That is called communication, shifting of information from end A to end B.
That's right.
This is communication, simple definition.
Communication. Yeah.
So now we need to plan after equipment. We need to plan this physical connectivity based on global standards. So now we will discuss this portion. What are the options we have? So connectivity, we have two options. One is wireless. Another
one is wired.
Wired. Wireline. Correct?
Yeah.
So once we talk about wireless, we have three things. Media till now. One is satellite. Second option is infrared radios. Infrared radios. Third one is microwave. Yes. Three options we have only. When to choose which one? This is also important, but we don't need to go too much in this what is the microwave and all. But yes, we need to understand what to use when. Satellite, once you need to connect some island or some mountain, there we use only satellite. It doesn't mean that some inland or some in a field you will not able to use satellite. You can use satellite anywhere. But generally
hilly regions, mainly hilly regions.
Hilly regions and somewhere in sea.
Yeah.
Islands which are not connected on fiber. For example, let me share with you. You heard this Lakshadweep, Andaman.
Yeah.
They don't have fiber connectivity. So all running on satellites. But in infrared radios and microwave, where fibers are not possible to lay down, for example, 20 kilometer, 30 kilometer, and due to some reason, laying the fiber is not an easy task. Digging, deploying, handling the authorities. So even maintenance, for every single inch, you need to check it out, maintenance. You need to do that for the fiber optics. But in wireless, microwave or infrared, only 2 points where you are installing. So for 20 kilometer, 30 kilometer, 40 kilometer, we are deploying infrared radios or microwave radios. Wherever more than 50 or 60 kilometer in the air, only the option we have satellite. So you got this point, where satellite we will deploy it as a connectivity.
Yes, sir.
where we deploy radios. Once
Radios.
radio means maybe infrared, maybe microwave, depends on the network planning or as cost or whatever team is available to handle. So you got this point, wireless.
Yes, sir.
Now wireline. We have two types.
Yeah.
You know, you let me know what are the two types in wireline. One is copper cable.
Fiber optic and copper cable.
Yes, only two portion, fiber and copper.
Fiber and copper.
Yes. Copper is electrical in nature.
Yeah.
Electrical signal. Signaling is electrical in nature. Fiber is optics, light.
Optics. Yeah.
So optical signal, no electricity. This is light. Once we say copper means electricity, we are talking. Electrical.
Yes, yes.
Once we say fiber, that means optical, no electricity.
No electricity.
Only light. So these are the options for connectivity. Now, 7 layers of OSI, we know already.
Yeah.
So very first layer is, what is this very first layer? Physical layer.
Physical layer.
Okay. So physical layer. Second layer is data link layer.
Hello.
Yes. Second layer is data link layer.
Second is data link layer.
Third one IP.
Network layer, right? Oh yeah. Sorry, IP.
IP or network.
Network layer.
So data link layer means Ethernet.
Ethernet, yes.
Here bits and bytes. Physical means all signal. So bits and bytes.
Signal.
Bits and bytes.
Bytes.
What is the technology work over here on physical layer? Technology works that is called transmission equipment, multiplexers, WDM, multiplexers. Have you heard this? SDH, synchronous digital hierarchy.
No.
Okay. Transmission, have you heard? Transmission equipment.
Yeah, transmission I have.
Transport equipment. So transport equipment technology is called SDH or PDH. Have you heard E1?
E1, no.
Okay. And STM1?
STM1, I think I've heard.
Sonnet, have you heard? Sonnet?
Sonnet.
E1 line, T1 line, Sonnet.
Yeah.
E1 line, T1 line.
But I am not sure about that. I've heard it.
It's like a E1 or T1. E1 or T1 lines. So, okay, no issue. Bits and bytes, you already know equipment that is working in this layer, physical layer equipment is called transport equipment, transmission equipment.
Yeah.
Okay. Technology is SDH, PDH, and OTN.
All these comes under physical layer, right?
Yes, all physical layer.
Okay. DX, SDH, PDH.
TH is transmission.
Transmission.
Technology is PDH. Evolution is PDH. Second evolution was SDH. Third evolution is OTN. Just now we have discussed scale planning. So,
sorry,
PDH,
first one. What is first one, sir?
PDH.
Second is SDH. PDH. Okay, first is PDH.
First one is PDH.
PDH.
PDH, we are getting E1, E2, E3, and E4. This is interface specification.
Okay.
2G is running on E1, 2G tower. In a mobile phone, 2G tower connectivity is happening on E1, on PDH.
E1.
Yes,
E1
electrical in nature. Okay. Interface, look, handshaking. Means if I'm speaking English and you are in Japanese, you will speak Japanese. I will not able to understand, although we are connected.
Yeah.
That means communication is not only transferring the data based on both side handshaking on same sync stage.
Two-way handshake.
Yeah. Means you both parties should be on every condition should be met, then only communication. Communication
can happen. Yeah.
This is nothing like only exchange of information. If you speak, I'm getting your information but not able to process it. So you can't say not exchanging. Information exchange is happening, but processing I stuck.
Yeah.
Because my encapsulation is different, your encapsulation is different.
Different.
So handshaking will not happen. So
what does PDH stands for?
please synchronous digital hierarchy.
PDH is?
Please, please synchronous digital hierarchy. Please synchronous digital hierarchy.
Okay.
Yeah.
And what is E1? E1, T1?
Coming on this. So once network has been invented, that was not for the data. It was for only telephonic call, POTS phone, telephone only. That is 50 years back, almost 50, 60 years back. PDH has been invented. Very first, nothing was there. No IP, no Ethernet, nothing. Only PDH. That is 50, 60 years back. And this PDH having three standards. One is Japanese standard, second is Asian, and third one is US. So total 3 standards across the globe 50 years back.
Oh, okay. Three is standard.
Yes, global standards. Japanese,
US,
Europe, and European.
Oh, Europe.
That's it.
No Asia.
Oh, Japanese, no Asia word, nothing. Only 3. Japanese, yes, you can say Japanese is Asian. So European and US.
Okay.
So you assume 50 years back, everyone deployed the copper cable network for telephone only, telephone calls, 50 years back, 60 years back, approximately. Deployed copper cable because no fiber, no radio, nothing. Only telephone calls on the copper.
Understood.
So interface connectivity was PDH, please synchronous digital hierarchy. So Japanese invented, so it works in Asian countries. US invented, works in only in US, and European only in Europe. So once people visualize some global network, they were not able to get synchronized because one was speaking English, one was Hindi, another was Japanese. So that means with 3 standards, you can't imagine global network. Intra-city within a country, that is fine. But international calls, no connectivity.
No connectivity.
Because no handshaking. So here but one thing is common in PDH, in Japanese and European, they have 4 interfaces, E1, E2, E3, and E4. 4 interfaces. E1 having a speed 2 Mbps, E2 is 8, E3 is 34, and E4 is 140 Mbps.
What does E stands for?
Electrical interface, so they stands for
electrical. E. Yeah. Okay.
So signal rate means anybody wants 2 MB, so you need to connect on E1. Anybody wants 8 MB, you need to connect on E2. Anybody wants 34 MB, you need to connect on E3. So Japanese and European almost same, little bit different. Signal rate was same, but Americans were different completely. Even they don't follow E1, E2, E3, they follow T1, T2. So T1 is 1.5 MB. Not 2 MB. So their signal rate was 1.5 MB. Approximately. Some 0 fraction, but approximately 1.5
Mbps. Okay.
Yeah. So now assume any global network international call handshaking, you are pumping with a speed of 2 MB and they are ready to accept only 1.5 MB. That means half MB packet drop.
Yeah. How many US are T1, T2, right? Only 2.
Yeah. No, T1, T2, T3, but different.
T3.
Yes.
And what was the speed there? 1.5?
1.5 is a T1 and 24 MB on a T2. So this was like that.
T3?
T3 same like 20, no, T2 somewhere is 6 MB or 24 MB. T3
okay.
Because they were running entirely different at that time, means 150, 60, 70 years back. They don't want to get in a sync with the rest of the globe because there was some Cold War kind of thing going on. So everyone was developing their own technology.
Okay.
Globe was not associated in a sync like nowadays.
Mhm.
So no global network.
No global network.
So that's why what is happening after some time, Asian countries and European countries agreed to make a standard, global standard, and controlled by ITUT.
Mhm.
ITUT
Is the body.
body, global body, or the
Global body.
EU, European Union also. Means ultimately they form one ITUT. So they starts controlling and everybody starts follow the standard across the globe, even till Australia. This E1, E2, E3, E4. So till 140, this is fine. But what will happen if anybody wants 200 Mbps? Did you got my point?
Yeah.
So that means at that time, Ethernet was not invented.
Mm-hmm.
Ethernet was not there. Not OSI layer was there. So they come up with second generation technology, that is SDH, synchronous digital hierarchy. This is second generation. PDH was first generation. This is second generation. So here they incorporate every PDH into SDH. Means whatever PDH was there, they carried out. So they carried out E1 to E2, E3, E4. Then next they form an interface that is called STM1. STM1 capacity is 155 Mbps.
Together.
Yes, on a one single port. Now anybody wants 300 MB. That means we need to add STM2. 2 into STM1, that is called STM2. So 2 into STM1, that is STM2. How many MB? So multiple of 155.
Multiple of 155, yeah.
We reached till 64 STM. That is called STM64. So that means what is the 64 into 155 Mbps?
So STM1 to STM64.
Yes, 64 into 155 MB STM1. That means you are reaching up to 10 gigabit.
Approximately 10 gigahertz.
Yes, gigabit. So that means reliability planning and connectivity planning, interface planning is the most important point.
Mm-hmm.
Where we want 1 MB, where we want few hundred MB, where we 10 gigabit. So second generation SDH came with a bigger interface, providing higher capacity. You got this
What
point?
is STM stands for?
STM stands for SDH transmission module. SDH transmission module.
SDH transition module. Okay.
They come with STM1 and they come with N into STM1 and N value, N stands for till 64.
Understood.
So whatever you bandwidth sitting on the network operation center, you multiplex. So this is called multiplexed. Multiplexers then came into picture because you are combining, means coupling and STM. Look here, if we transmit, that means we are doing multiplexing.
Yes.
So at the end of TX, at the receiver, we are doing demultiplexing, demarks, means separation. So here you club 5 multiplex STM1, here you separate into 5. So this is called multiplexing and demultiplexing till 64 STM1. That means up to 10 gig. So starting from 2 MB on a physical single port, now you can have 10 gigabit on a single interface. This was the journey. 10 gigabit. How? First phase was PDH. And second phase was SDH.
SDH.
So this is the interface connectivity. Let it be in any domain. In infrastructure planning connectivity, you need to remember these interfaces and capacity planning. and this is the logical interfaces running on the physical interface. Logical capacity is the logical, correct? Now, nowadays, even we are talking, so means you, let us assume at our home, we are talking 1 gigabit internet connectivity. So towards the cloud connectivity, how much big bandwidth we require? Almost 100 gigabit.
100 gigabits.
Because after connecting 10 houses, it is completing 10 gigabit. And there are country like India, there are billions of houses are there. 10 gig is enough towards cloud side? No. That means we required 100 some big bandwidth interfaces.
Yeah.
But SDH says after 10 gig, SDH exhausted. No further development. Limitation reached. Technology exhausted. Till 10 gigabit, yes, SDH is fine. More than 10 gigabit, no SDH. Then another technology came into picture, and this is third generation. Third generation, once I say this is going on, means in our generation. Currently, this is called OTN. Have you heard OTN? Optical Transport Network.
Optical
Transport Network. Optical Transport Network. OTN came into picture, third generation, and it says, I will give you 2.5 gig. 4 interfaces they define, 2.5 gig. 10
What
gig.
are you talking?
Mm-hmm.
What are you making for that?
40 gig and 100 gig. 4 different interfaces. This is OTN came into picture.
What are you making?
Third generation, that this generation is going on right now. We are at third generation. So backhaul connectivity, you need to understand this, because once we discuss 4G and 5G, OTN is going to play a major role in connectivity.
Yeah.
No
Could you
SDH,
please
no
explain
PDH.
this again, sir? Could you please explain this again?
Yeah. PDH, first I'm explaining OTN. Till 100 gig PDH was fine, you understood?
Yes.
Once more than 10G we thought, then SDH exhausted. No beyond 10G SDH talking about. That means we required some technology who can handle more.
Yeah.
So third generation technology came into picture, that is called OTN, Optical Transport Network. This OTN has 4 interfaces, standard interfaces. One is 2.5 gig, second interface is 10, third interface is 40 gig, and fourth interface is 200 gig.
Okay.
So from the single port, 100 gig I can support. Now let us assume, if in any society do you have 100 houses and everyone wants 1 gigabit, now my link port can be connected towards cloud with 100 gigabit on a single port.
Yes.
With help of OTN.
Yes.
So huge bandwidth can be served on a single port.
Yes.
So this technology, now I am clubbing with mobility. That means PDH, first generation, second generation transport, and third generation transport. First was PDH,
SDH, OTN.
Maximum capacity is 140 per channel for 140 MB.
Yeah.
This is maximum is
24.
No, I'm talking about SDH. 10 gigabit maximum.
10 gigabit. Sorry.
10 gigabit.
SDH, 10. Yeah.
And in OTN maximum is 100.
100 gig.
Yes, so this is the maximum. In 3 generation. See this one. This 3. On a single port.
Yeah.
So you got the difference?
Yes, sir.
You don't need to enter too much in PDH, SDH, and OTN, but yes, you need to remember these interfaces and connectivity types.
Correct.
Be it or any domain, or be it or any profile career in a IT or telecom. You need to know interfaces and capacity.
Yeah.
Now, this was running on a 2G, required for 2G connectivity. This required for 2G and 3G both. 2G and
3G.
3G both. this required 3G and 4G. 3G and
4G.
4G. And yes, 5G as well. 5G.
Third generation. Yeah.
Yes. But in a 5G again, there is a limitations. Not we are widely accepting, but 5G wants 400 gigabit uplink.
Wow.
Yes, 400 gig and here I have not written 4G anywhere. So here we required fourth generation because OTN says after 100 gigabit I'm exhausted.
Here people have started talking about sixth generation now.
Yes. And unfortunately here technology are not in a mature stage. Here we are talking 400 gigabit on a single channel.
Yeah. Even in Japan, it is not stable. 5G is not stable. They have a lot of issues going on.
There are two major challenges. First major challenge.
Sorry. Yeah.
First major challenge, generation 4. Fourth generation, I'm talking about backhauling, transport, not on a mobility side. I'm talking about carrier side. Fourth generation is not matured still. We are doing some makeover kind of thing. Some POCs is going on in industry somewhere in Japan also, in different countries. But it's running from last 1 year, 2 years, 3 years like that way. But not in a widely accepted mode because they have not matured enough.
They are having a lot of latency issues, sir, on 5G.
Yes. So, look, this consumes latency first. And one, even right now, I'm not talking about the challenges itself 5G technology. This generation 4 is not dealing with any 5G only 5G encapsulation. This is handling only, I'm talking about transport right now. 5G encapsulation, what is the challenge in handling encapsulation of 5G packets? This is another challenge. But how to carry that packet of 5G packet as a transport, because already we discussed in a first discussion, let a transport like a transport only, don't push too much processing on this.
Correct.
So with this statement, even your stage 4, generation 4 transport is not matured, still in like a testing mode somewhere, some invention is going on, some testing is going on, like that way it is going on.
Yeah.
Matured in technology like PDH, SDH and OTN.
So most of the people here, they don't know the technology. They're actually pushing them to learn the technology.
Look, just now we discussed two things. First, talk about physical infra. Talk about logical infra on top of this. Then how to do the management of this physical and logical. Then we required all application. Till then, don't talk any third thing. First, talk about first and second thing. Point.
So here they are actually facing a lot of issues. So that's why what they did from Japan, 5G thing is not working out. They move people to Singapore because you know Singtel, right? So
yes,
from
I know.
there, so the entire 5G process was done from Singapore, and most of the people, just because they can't speak English, or those who can speak, they have pushed them from travel agency to 5G projects. And like e-commerce to 5G projects.
So this thing is, I don't know right now. My perception is, I have seen that few companies, they are forcing their internal employees. So what I seen, this is kind of only money making like a early bird. But on ground, nothing is happening on even Indian, because I'm handling two companies almost, Aricent and one is Accenture, aggressively following. But let me clear you very much right now. If scientist level, R&D level, they are still in R&D level, how a one network guy can deploy and all this thing? So simply they are making a good presentation, forming a virtual world and making money.
That is what our guy is saying. Our guy is saying we are still not ready with this.
Yes.
And why do you want? Yesterday there was one meeting where he clearly told 6G. You're saying 5G, 4G itself is not in stable position.
Yes.
And with 5G there is a lot of issues going on. The reason they are pushing because for cancer treatment they want to get 5G. And here he's working on the cancer treatment only for your head to chin. Okay, till there. So for that they are planning to do a lot of improvements. They are trying to work upon to see how this can be done. But I have people who actually work for Rakuten Telecom itself. So they are saying every alternate day there is a latency issue. Every alternate day we have a data center issue. And there is
Look, 5G is all latency game, resiliency game. That's it. All timing.
Resiliency, yeah.
Yes, all timing. How you will manage
Mhm.
this timing? Even you leave the millisecond word. Even a nanosecond disturbance, your real-time application will be disturbed. And one
Understood.
here, your fourth generation transport is not available. They are still under like a makeover thing scenario. There is.
Mhm. They are actually competing Netcracker because Netcracker is working on the Nokia RAN project, right? So that's why they are trying to do such things.
No, what is happening? Everyone is working in domain like a PDS. Did you remember American standard?
Yeah.
Same way in every, now I will not say continent, I will say big companies. They are working. They are in within own domain, within one own like a proprietary kind of right now. So who's first, they will earn big money because their adaptability across the globe will be there. So everybody is working like that way, not in a handshaking mode. Even in Jio is they developing their own 5G. Airtel is developing their own 5G.
Yeah.
The concept is there is one technology. Let me. I don't know you heard of this word or no. Flexi. Have you heard this?
Flexi. I think. Yeah.
Flex, 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 and E means Ethernet. Flex Ethernet.
Flexi.
This is a very common word for 5G transportation.
Okay.
Flexi. So Flex, what they did in a Flexi, you see this OTN 100 gig. This 100 gig OTN maximum capacity is 100 gig on a single port.
Yes.
So if I will add 4 port P1, P2, P3, and P4, and all I multiplex with help of some multiplexer within a chip and club it and pass it on one physical port. This is my Flexi having 4 gigabit per second. This is makeover kind of thing. So everybody is developing this chip.
Oh, so they are pushing it. Yes. Oh, that means they're pushing it.
Yes, they are saying, okay, I develop one chip with help of software and some algorithm. I try to control the signal and pushing out a 400 gigabit on a one port. You buy it, you connect it. I will code it, I will decode it, the transportation. So this is all proprietary going on right.
Okay, understood.
Yes. So here in this case, so this is the major challenge for transportation. Second challenge that we will discuss when we will discuss 5G and 4G encapsulation connective. 5G actual technology. Right now we are talking only transport area, not 5G.
I had one doubt. Okay, you were talking about in the beginning. Okay, so it was in the beginning. So you were talking about the fast Ethernet. Okay, fast Ethernet. When you said do we have any specific Mbps like the speed limit or measurement?
Yes.
What is the like industry standard or how do we actually measure this?
First standard on a layer 2. First thing is listen. PDH, SDH, and OTN all are on layer 1.
Correct.
Layer 2 is Ethernet. That will L2. L2 is L2 is Ethernet.
L2. Okay. Later we will talk.
Ethernet having FE. Another specification signal rate is Gigi. Third one is 10 Gigi. And fourth one is Flexi.
100 Flexi.
So this is 100 MB.
Yeah.
This is a specification. So this was the question you were asking?
Yeah. No. There actually, when you were explaining the complete Ethernet port part, so you were saying that you gave that example, right? Where it is like that 8800 example where you were giving, like a customer has requested for 10 gigahertz.
Okay.
Can we
10 MB, yeah.
Yeah. So I wanted to know FE, you told, right? I mean, does FE has any limitation? That's what
yes, I want. 100. This is the limit.
100 MB. Okay. Thank you.
Flex is 400 gigabit. 400 it means 40 into 10,000. 400 gigabit. 40 into 1,000.
1,000. 40 into 1,000. You want to take a break, sir?
Yes, after this Ethernet.
Okay.
So 400 into 1,000 gigabit. So right,
400.
need to remember
400
fingertips.
Okay,
400 giga means 1000 MB. So this you need to remember. This is the option.
understood.
So flex is only talk about when 5G is there. Otherwise, no need to talk.
Got
Right?
it. Sir.
Question
Yeah.
from Ethernet side.
No, sir, clear.
Okay. So we were discussing under this reliability planning the connectivity with physical interfaces and in a ring architecture. So we already discussed this. Available on layer 1 as per OSI and layer 2. So now summarizing layer 1, that is already we discussed PDH,
PDH,
SDH,
SDH,
and OTN.
OTN.
And here only Ethernet.
Yeah.
And within the Ethernet types are FE,
FE, GE,
Gigi, 10 Gigi,
Gigi, 10 Gigi,
and
Flexi.
And Flexi. So this you need to remember.
Understood.
So now, apart this, there is one more transport system has been invented, but that is not the part of layer OSI layers, because
Okay.
OSI says layer 1 to layer 7. Layer 1 to layer
7.
But industry driven, there is one more layer now that is called layer 0.
Layer 0.
Yeah, have you heard?
Oh, no.
This is
Totally
industry
new.
driven. Yeah, this is industry driven, not as per the ITUT.
Okay.
So what is layer 0? Because earlier network invented from PDH connectivity, and
Yes.
PDH is electrical in nature because even E2, E3 electrical interface.
Mm-hmm.
Fiber optics invented hardly 20 to 30 years back, 94, 80, something like that way, 80 and 90 somewhere. 90.
Sorry, I missed that part. Your voice got disconnected.
Okay, so electrical invented 50, 60, 70 years back from now.
Yes.
But optical, fiber optics is somewhere in a 1980 or 90, somewhere like that.
Mm-hmm.
Not exactly remember, but somewhere 1980s I remember, by some Indian, one Sardarji guy was there.
Okay.
So this fiber optics, that is in nature is the optics light, but OSI standard defined 50, 60 years back, but fiber 30 years back. So in a layer 0 is basically a optical signal, optics.
Mm-hmm.
Optics, light means lambda, wavelength.
Mm-hmm.
Have you heard lambda?
Yeah, lambda.
Yes, so wavelength, lambda. So this optics and wavelength is defined under layer 0, and this is called photonics layer. Why photon? Because light having photon. So layer 0 or photonics layer. Have you heard this photonic layer or L0?
No, never. First time.
Okay. So this photonic layer deals only in optics, no electrical signal. Layer 1 can handle optical and electrical both.
Okay.
Layer 2 can handle optical and electrical both. But layer 0 only optical, no electrical. So here in this case, technology came into picture apart than SDH, PDH and OTN or Flex E, WDM system. Have you heard? Wavelength division multiplexing.
WDM.
Yes, wavelength division multiplexing.
Is it something like the WCDA, something we have?
No.
Okay.
This is categorized into DWDM, dense. DWDM.
Mm-hmm.
So DWDM, dense wavelength division multiplexing. So in an optical, there is only one technology, that is DWDM. You need to remember.
Wavelength, density.
Dense.
Mm-hmm.
Wavelength division multiplexing. So for the transport, let it be 2G, 3G and 4G. layer 0. Now you can define layer 0, layer 1 and layer 2. You have total 3 for the connectivity. Layer 0 is DWDM. Deals only optical. Already we noted down PDH. Plus SDH. I'm writing short form. And OTN.
OTN, yeah.
Dealing optical plus electrical both. Signal. Layer 2.
This is for layer 0.
No, this is for layer 1.
Layer 1, sorry. Okay.
Again, I'm now not writing Ethernet. Already we FE gig we noted down. So here optical plus electrical.
Yeah.
So this summary you need to remember.
Okay. So
in any technology.
L0, it is DWD DM, which is 0. Then
0 nahi, this is optical. 0 means
optical. Optical. And for L1 it is P plus S, and OTN, that is optical plus Ethernet. And for L2 it is
optical
Ethernet
plus Ethernet nahi, electrical.
Electrical. Yes. And for second layer it is Ethernet, which is optical plus Ethernet again. Yeah.
Electrical.
Sorry.
Correct. Because look, ultimately at every section, every point, if we are crossing, we need to check it out, the media encapsulation protocols. That's why it requires. Somewhere you are receiving, you are at receiver end, you are receiving electrical and your nature is optical. How it will be synced? That also you need to check it out for every section, every patch as an connectivity. You got my point? So in terms of physical connectivity, that's why day one I share with you. If you close your eyes, your signal flow should be clear in your mind, clearly visible. Okay, it enters from this port, enters in electrical form, then come out from this port. Now it is going on an optical form. So this journey should be visible to you in your mind. So once we say cloud, it doesn't mean that this is nothing is visible. Everything is visible in your imagination. Okay, my signal flow is going within the cloud this way. So there is nothing like that within the cloud. Where it is, I don't know. No, we know where it is. Yes, if you're handling application, then definitely you don't know where it is. But if you know architecture end to end, then you must know where it is. Then only you will able to do the diagnosis. Point? Okay. So now third one is the deployment planning. Deployment planning is the same way, like where is optical, where is electrical, then handshaking of 100 gig to 10 gig port. So generally we do same signal rate with the same signal rate. This is nothing like you can connect FE port to 10 gigabit port. It's a wastage of resources. Physical port, that is fine, but wastage of logical resources, because FE is 100 MB only. And this is 10 gigabit. 10 gigabit means 10,000 MB. Is this wastage?
Yeah.
Not efficient planning.
Not efficient planning.
Software and hardware configuration planning. Yes, what hardware, what like because every equipment has its own processing power. So as per that processing power, you need to get the software and licenses.
Yeah. Asset, your asset and all. Yeah, understood.
Yes, like Splunk in NMS, if it can handle only 50 users at a time, concurrent users, why I should buy a software who can handle 500 concurrent users? My application is supporting only 50. Buying the licenses only for 50. I should not invest 500 concurrent users or 100 concurrent users. So this is a combination of software and hardware as per the need. 2 years, 5 years span of time.
Requirement, as per the requirement. Yeah.
Correct. And consumption rate.
Consumption rate.
So some hypothetical calculation based on consumption rate. So we are speculating.
Hypothetical calculation based on consumption rate.
Yes. Current consumption rate, you can predict the future. Let it be 10 to 20% with 10 to 20% variation. But it should not be that, okay, you assume 20%, 30%, and your variation may differ on a 50-60%. You hypothetically calculate based on current calculation plus current consumption plus 20% variation. Generally, we do in practice, industry practice.
Yeah.
Now, OSS interconnection planning. This OSS interconnection planning, we require dedicated protocols. We will discuss later on. We will not discuss OSS, but we will discuss the connectivity point of view, like how to connect, like your servers, servers with what protocol you require, because different team. It's a different team who will handle. But as a project manager or as a SME for end to end, you need to take care of all this.
Understood.
DCN network planning is basically a management of entire this infrastructure.
Complete.
Yes, complete. Sitting here, I will be able to handle all, able to reach. This is my DCN planning. So,
DCN stands for
data communication channel network. The data communication network stands means I'm not talking about customer traffic.
Setting up our own infra.
This is internal management of the infrastructure traffic.
Correct.
And this is not exposed to any customer traffic. This is internal. Whosoever sitting in NOC, whosoever sitting in SOC, it has only the accessibility, because it's
internal.
Yes, it's separate from customer traffic. This is management of traffic. If your now question, if your DCN is disturbed, your customer traffic will be affected?
Yes.
No, before this I said one line. DCN is separate.
Failover. Okay, understood.
No, nothing failover. DCN is virtually in the same hardware. Hardware is physical hardware is same, but there is a two virtual memories running. One virtual DCN, one virtual memory for this customer traffic.
Yeah.
So your DCN is disturbed means your another virtual memory is not going to disturb. Let it be in the same hardware.
Okay. But see, but if it is what do you say, primary and secondary?
I'm not talking about ring topology or any any failover plan. I'm talking about let it be primary or secondary. My concern is primary also fail, your secondary also fail. But due to some reason, your DCN is disturbed means you will lost the management of your device sitting into NOC, but you will not lost the customer traffic. Customer traffic will running on as it is. But yes, you will lost the accessibility, but customer traffic is not going to disturb. See how, don't remember, understand the logic. Management, look, very first we plan hardware, that is fine. First step we discuss. Then second stage our planning for the logical resources. Third stage is physical connectivity with interfaces. Till now we discussed. Fourth stage is after physical connectivity. Let us assume you opened a new telecom company. So day one you are not going to hire any subscriber. First you need to establish a network. Correct? So for you are in the third stage. You connected physical with help of interfaces of Flexi, SDH, OTN and all WDM. Now you are doing setup of NOC or SOC. NOC I am doing setup not for the customer, because customer will come later on once business will start. First I need to monitor my infrastructure. Internal devices. I need control. That means, do we need some mechanism?
Yes.
So this control is DCN, data communication network channel.
So I have a question here. Okay. So maybe I don't know whether it is related or not. There was a major challenge which we actually faced it when still we are facing with my previous company. Okay, this is on VoIP. Okay, I'm not maybe I'm not sure whether it is related or not, but still all the other networks what we have, like dedicated customers, and this is a shared network. It is a TNM, managed service, where we have a service desk team who is actually working here. So I have Avaya phones from here, which was given by customer, and whatever calls are landing from that company in US, California, from there to India, okay, it is coming from a third party call. So sometimes what happens when I have my network drop or a packet loss here, I miss one of the calls which is actually there in the queue, but I miss that call here. Like it gets, it's like my network got disconnected, but the call has landed. So that is like a rollover next agent. Okay, the call goes to the next agent. And we get, when we do initial check from the network team, they tell us, okay, there was a packet loss during this time. Okay. So for that, customer was not happy, and customer had a lot of complaints on this because this was happening. Customer was not ready to give us a direct dedicated service. I mean, was not ready to pay for the internet service. And he said you have to manage it from your infra, from your ISP only. So we had like primary Airtel and secondary as Reliance. So whenever Airtel is dropped, and immediately when Reliance comes up, so in between like once in a month or twice a month, we used to have that disconnect, and we used to lose 1 or 2 calls. So I'm just asking. So it is an internal. First of all, it is an internal loss where we had a packet loss, and apart from that, customer is actually. I mean, we on Citrix how we are connected, and on Avaya how we are connected. That is through this company, my XYZ company. Okay. So there also customer is also losing a call. So is it something like DCN network issue, or is it only for my existing company?
It's not DCN purely. Okay, let me draw one thing, then you will come to know. I will not say DCN to failover. I will explain to you.
No, I'm just trying to understand.
Yes, that is fine. No, that is fine.
This has been a risk for us, and we actually lost the project also. I mean, that is a different situation.
No, let me share with you one example. Example I will share. One, let us assume they are connected via this way. One telephone line is here and one receiver is here. Okay, and one knock or SOC is here who is monitoring customer or infrastructure both.
Yeah,
correct. So first I will talk about infrastructure maintenance. Customer later on, because if my infrastructure is fine, my customer will be fine. So my first priority is to protect my infrastructure first. So customer traffic is running. I'm making two-way via this is my traffic. Correct. And this my, let us assume Airtel. ISP 1.
Yeah.
ISP 1. And this is my ISP 2 in terms of failover.
Yeah.
So first I need to monitor my infrastructure, customer later on. So sitting here, 2 signals are going on. This is my signal 1, signal 2, and third signal is also going on. What is this third signal? Let me try you. I create one signal that is running between this 4 transport devices and coming to the knock for the visibility and control.
Correct.
So this yellow is my DCN. Nothing to do with any failover and customer traffic. From pink and this blue, nothing to do with this yellow line, yellow path signal. So if my any signal is getting, let us assume this is disconnected from here. My S1, S2 will disturb.
Yeah.
Signal 1 and signal 2 will disturb.
Yes.
No.
Oh, no. As signal 1 and signal 2 will not disturb. Correct.
Because signal 1, signal 2 only require physical path.
Correct.
They don't need to come to the knock.
Yes.
Because this is customer traffic, not the management of infrastructure. Knock has the visibility of S1, S2, S3. S1, S2, I also control sitting in the knock, but S1, S2 is not coming to the knock. So my DCN is getting disturbed. It doesn't mean that my S1, S2 will disturb. Yes, sitting in a knock, I will lost the control of my infrastructure if any disconnect, but services will be running fine. Customer is not going to face this problem, any disturbance.
How, sir? How is it possible? Because see, if I am connected via customer, then my infra itself is down here. How will I be able to?
Infra down means what you predicting?
When I'm saying, see, I'm sitting on knock here. And okay, the ISP what I'm using here is from India, but I am connected via, what do you say, Citrix.
Mhm.
That means I'm not able to connect with the customer's portal itself, right?
Mhm.
The customer also has got disturbed there.
Let us come on this left hand side picture.
Mhm.
Customer is, what is the function of this layer management application? Only control and visibility. What is
Yes.
what is running here? So only the control and visibility.
Yeah.
Customer traffic. What is the signal flow of customer traffic? Signal
Via my ISP. There is no, sir. Customer doesn't have any
means
dedicated.
entering here and coming somewhere here, like
Correct.
that.
Yes.
To go upside.
Hmm.
I don't need to go up layers. See the difference. Third layer has the visibility of the event only. What was the use of third layer? Why we did this layering? Management of the bottom layer, I required capturing. So NMS has the function for capturing of information and executing the instruction. That's it. So anything goes wrong in this connectivity, my customer traffic is not going upward. My DCN is going upward. So only DCN will be disturbed. My customer traffic is going this way.
No, customer. See, customer. I'm not talking about customer traffic. I understood that part. I know customer. See, customer has a different line. Okay, he has only given us the services via Citrix. That is through our ISP. I understood that part. So I am saying here, customer is getting disturbed in the other way. Other way in the sense is like because of my disconnect or because of my failover, that 30 seconds or 45 seconds where I have some calls which I am supposed to get on my knock or on my service desk or with my any of my managed service team, I am losing that. So customer, when he's trying to connect with us, that there is no what do you say, communication. To overcome such issues, we are actually having a lot of what do you say, customer is saying you come up with a dedicated service, so dedicated line. So here there is no dedicated, it is like one shared service where it is actually with one shared service we are running the entire what do you say, infra
on a physical path.
That's right.
See, now coming here, this S1 can have many services running on a shared way. Correct?
Yes, sir. Now we are on the right path.
Service 1,
service 2,
service 3.
Yes.
Correct? Now,
yes.
one coming. Let us assume there is a disconnect over here. We need failover.
That's right.
So switching will happen on this path.
Yes.
So once switching will happen, layer 1 has a standard that we already 50 millisecond. Within, not I will say 50 millisecond, within 50 millisecond, less than 50 millisecond. Okay?
Yeah.
Layer 2, and this is guaranteed every time. Guaranteed.
Yeah.
Layer 2, 50 millisecond to almost
Sir,
5.
Oh, sorry to interrupt. Are you saying it is 50 milliseconds?
Yes.
Okay. It is industry standard, you're saying, right?
Yes, ITUT, global.
Okay.
Then only I will accept. If anybody is not giving me on a layer 1, then I will not accept the link. I will not pay. My SL is disturbed. Quality is not, this is not a reliable link.
Okay, this is something valid point you have told me. Okay. Yeah.
I'm coming on your phone. I know. I faced this one problem. That's why I'm share one. I faced once. I was one AT&T client.
AT&T, I know how they are. They are worst.
In following up. For one issue, they put one engineer for even a month. Please ensure it should not occur again.
Oh God. Okay.
So now see, layer 2, 50 millisecond to 500 millisecond.
Yeah.
And this is not industry standard. We have not matured still. It may vary configuration to configuration. Customer to customer.
Yeah.
May vary. What will be the impact? Now I'm sharing on this. Now coming to layer 3 also. Layer 3 is IP. Layer 3 is IP. You know IP router?
Yeah.
So router has protocols. You heard OSPF, BGP. You heard this
Yeah.
three
Yes.
protocols.
Yes.
They have the failover switching also, but they also not ensuring 50 millisecond. It could be anything between 50 to 500. All depends on configuration, on traffic processing. So who is the reliable in a OSI layer as a transport? L1 is still reliable as a transport. These two are not reliable. Means yes, we reached up to, but not guaranteed every time. We see the statement. L1 is reliable. L2 and L3 is almost reliable. You got my statement?
But not as per industry.
Yes, because many factors are there, and I will share that example of AT&T. You will come to know. You understand these three lines?
Yes.
First line is 50 millisecond.
50 milliseconds.
Yeah. So any switchover will happen, and let us assume you are running on a dedicated leased line. Leased line is layer 1. Leased line is layer 1. So 50 millisecond recovery. Now coming on service V1. I'm sharing this AT&T example. Here they were running some real-time application. Real-time, once we say this is a kind of SIP or VoIP or any other application. With help, their application timer was fixed on 30 millisecond. If my session starts and disconnect more than 30 milliseconds, then my session will be break. You got this line? I establish V1 from here to here, one session. Server is there and my application is here. I established one session. Failed over occurs. Set my application timer 30 millisecond to wait. Then break the session. You got this line? Visualize this line. In application, I mention during development on a software guy whosoever fixes this, keep the session on a 30 millisecond interruption. If I am,
that is the target, understood.
Yes.
Excel limitation. What
yes. So after, if I enters into 31 millisecond, in a
it
way,
will break the session.
You break the session again, you reestablish the session for new session.
New session.
So in AT&T logs, like VoIP or any real-time application, they are capturing the packet loss, disconnection.
Yeah, that's right.
Disconnection, some frame loss. Every disconnection have some frame loss, some packet loss.
Yes.
They are reporting, and we were running on a 50 millisecond, and 50 millisecond is not the configuration, it is the pre-embedded into a chip protocol during manufacturing. So you have nothing to do with this configuration in a layer 1. So what you will do in configuration? If ITUT certified equipments are there and you don't have anything for configuration because it is pre-embedded into chips during manufacturing into factory. So now you lost, now what to do? So now coming to your problem. And first I'm sharing this AT&T analysis. So we lost almost 5 to seconds. Then we asked, give me your router or where you have configuration you have done for your application, give me the configuration. Due to security concern, they are not ready to share. We will not share. Because ultimately, just now we have discussed, handshaking requires for communication, correct?
Yes.
And not transferring, that is fine, but handshaking as well. So your configuration and my configuration should be in a sync mode.
Sync mode. You have 30, I have 50 will not make sense.
Yes. So what is happening? I am not saying 50. Any traffic switching is happening. This is within a 50. So sometimes, how we are stuck with AT&T, we give the example, we give the reason 50 millisecond switching happening. So you are getting some packet drops and interruption. Or maybe possibility, my leased line taking more than 50 millisecond switching. That's why you are facing interruption. Start saying, no, sometimes once switching is happening, so we are not facing any disconnection. Sometimes we face, sometimes we don't face. Means whenever switching is happening, sometimes we lost the session, sometimes we don't lost the session. You understood this line?
Yeah.
So what is happening once switching? So once I say less than 50 millisecond means within a, Sometimes it is taking 40 seconds, sometimes it is taking 20 milliseconds on.
20 milliseconds. Okay.
And there is one BGP protocol, you heard? IP protocol.
BGP protocol, yes.
In a BGP, there is a timer session.
Yes, yes.
In a router, there is a configuration command line, CLI command line on a Cisco.
CLI command.
Yes, you need to configure on the timer for the section. They have not shared. This call escalated to the CTO level. Global CTO head there, they referred this call. Then he approved for the configuration because they have not shared what protocol they are running. Then his CTO approved, then he shared with us in a confidential manner. Then we review their this configuration. Then we came to know in a BGP, they have mentioned less than 30 milliseconds. And switchover is mentioning less than 50 milliseconds. So whenever switching happening less than 30, so no disruption, but once taking less than 40 milliseconds, disruption will occur.
Yeah.
So where is the problem? BGP session?
BGP session, yes.
No with service provider.
Understood now.
50 millisecond is the ITUT global. You can't change it. Then where you can change it? Router is giving you, BGP is giving you this facility.
Yes, yes.
Who is controlling this BGP? Customer.
Customer is controlling it.
So whose problem is this?
So customer is not ready to share the configuration. Yeah, that is there for us. That is already there. This issue is there from a very long time.
I handled for 1 year. Means I was at that time somewhere I was about to displace from this process. But later on in this BGP session, we got it 30 milliseconds. And
sir, our customer was so demanding. Imagine, sir, industry standard when we spoke about it, he was saying 100% call handling. Who does 100%? See, 5% of leverage is already there. We are saying at least give a 2% of leverage. He's like, no. Even with quality, he wants 100%. Then we had to show him the fatal and non-fatal errors. Okay. He has see quality sheet. I think you would have seen a quality sheet, not more than 12 to 15 lines for a ticket. But his quality sheet, there were 38 items, sir. Starting from the call received on Avaya till the call got over, and after the CSAT, like what we have received, for every single second, he was like, you have to actually do a audit for that. So that kind, we actually did a benchmarking where we actually did it for few projects, and we told customers, see, these are the service desk or help desk way of handling calls. But still they say, okay, our call, this is how we do it. You have to follow. This is the audit, and no matter what it is, and if an agent gets less than 90%, the agent has to be removed from the project immediately. Every week, we used to do this call audits, ticket audits, and all. 90, it's like 1 or 2 agents, maybe. I think we had to like try to like put some what do you say in school? They say, right, give some grace mark kind of thing. And if we do that, customer will ask us, why did you do this grace?
No, in this case, look what is happening. I have seen that in IT processes. But being because since I'm not the part of IT, I'm the part of pure telecom. I faced such type of problems like I was going to deliver the links to any data center or any IT guys. They are talking like that. I agree with you. Industry talking like that. But you come with the facts, with the industry standard. Like example, if 80 will force me to make it less than 40, how I can do? Even scientists can't do. So I can fight in a brutal way, no issue. So after this, we fight it like a brutal way. Okay, come in that way. You want to change the industry standards? Go to the ITUT. Ask the scientists, R&D guys, who is sitting globally on top of this. So my concern is, yes, if somebody who is sitting in front of me who is logically sound, I can keep my. This is in the look technology limitation. You can't change it. We can't change it. So once we came with this, everything gone, everything settled. But yes, We will not talk like that. Okay, this is industry standard and all this word. Yes, we should come with the facts.
Facts.
I'm saying, I am asking you again and again. First, protocols, industry standards, physical connectivity, logical connectivity, signal flow. You should be very much clear. Then you will come facts to whosoever in front of sitting in front of you. Then we don't need to worry. Even if we know the facts, if I'm talking to my CTO, I will not worry at all because I know what is. I'm not saying this line. This technology is saying this line. Scientists designed this way, this line, this way. So I'm talking that way. So here take is switching on a layer 1. You please remember this is guaranteed 50 millisecond. Any application they are if configured less than 50 millisecond, this is not industry standards and we can't.
Understood, sir.
This is their problem.
Understood.
Layer 2, layer 3, yes, I agree. In this case, we need to check our configuration as well, customer configuration as well, and switching time. Yes. So please remember this tool.
Sir, one more thing. L1 you told 50 millisecond, L2 50 to 500 millisecond, L3
same.
Okay, both are same.
Yes.
It was not clear.
Now they are giving 50 millisecond L2 and L2, but I can't say 100% every
But
time.
still in discussion. It's still in progress. In discussion.
Yes, somehow we got simple one-liner you can understand. Recovery within guaranteed 50 millisecond layer 1. This is my first statement. Second statement, layer 2, layer 3, almost recovery 50 millisecond guaranteed. Almost. I added the word almost. Now you can differentiate.
Yeah.
So this is the line. So any application, Citrix or anything running on a layer 2 or layer 3, no guarantee. Whenever switchover will there. There may chances. With help of, you heard the word QoS, quality of services?
Yes.
So with help of QoS, you can control with policies of traffic policies, but guaranteed, nobody can give you the guarantee. They are only ensuring words. Listen, ensuring 100% within a millisecond recovery and giving guarantee. Insurance and guarantee both are different words.
Guarantee, yes.
So this is the difference.
QoS is what we gave. QoS is what we actually proposed. But customer was still not ready with that.
Yes.
He's a demanding customer.
You can say, so that's why network, so end-to-end network you diagnose where they are shifting from layer 1 to layer 2, layer 2, 3, what protocol they are configured, what time.
They don't want to share the network diagram.
That's why.
Simple.
I share with you one.
You gave that AT&T example.
Yes.
That's pretty clear.
Even at that time, I was about to lose my job due to this.
Yes. I mean, even we had the same problem. Yeah.
Yes, I fight with my management. Okay, you terminate me, but give me one time at least. Give me this one configuration. Facilitate me to get this configuration. AT&T configuration. They call their CTO. CTO to CTO talk happened because it was a big account.
Yeah. I know.
4 to 5 crore annual turnover was there from one client.
Same here, sir.
Yeah.
6 crores, sir. 6 crore business. For service desk itself, we used to make like 2.4 crores.
Yes. So, but anyway, concern is sharing this problem with facts. No issue. But yes, fact means this facts you can't go take this facts to the any management guy, techno management guy on the upper level sitting with them. You can talk so that he can make them understand. Because I will talk to customer higher level people with facts, they will not listen to me. I will go to my not management, techno management people who is sitting on top of this like a CTO or level. He will make them understand. This is the facts.
Understood.
So this interconnection, DCN networking, you got it?
Yeah, understood. No, understood.
Okay. So now in this slide, although it's looking only one slide, we almost completed this whole discussion on a one slide, but it includes so many discussion and logics within a one slide only. So now we are open. Any query, any question, then please ask. Else we can close today's session.
Yeah.
live attendance
Uh,
discussion.
security planning and configuration tomorrow will continue.
Entry into security right away is not possible.
Not okay.
Well,
Understood.
first we need to understand this. Here you see this XML, CORBA, SNMP, FTP word is written. So we will not go into depth of this, but yes, this first we need to understand. Then we will enter security planning.
Okay. Understood. SNMP. Okay. FTP and all. Yeah. Understood.
Yes. Okay.
Okay, sir.
Thank you.
Bye bye.
Thanks for watching. Don't forget to subscribe to our channel.